This is CS1101, Lecture 8.1. We're going to be looking at using files as sources of input to a program. So far, anytime we've needed to get input into a program, we've used the console, so directly typing it in, and we've declared a scanner object and pointed it at the system.in location to be able to get that input. But a lot of times we need to not only deal with interaction with the user via the console, we will also need to be able to access data stored in files. In CS1101, we're only going to deal with text files, so that'll keep things a little bit simple. The way to gain access to a file in Java is to create a file object. Now, that doesn't mean that we're creating a new file actually on the hard disk. What that means is we're creating a new object in memory which is going to be used to read the contents of this specific file. The way that we would go about this is going to look something like the code here. So first of all, we have to import the library to be able to manipulate and read from files. Then in our code, we declare the file object with the location of the file as the parameter to the constructor. So this will construct a new object, that is, allocate the memory and give an address for the location of this object in the heap, and then we're assigning the location of that object into this file variable f. And we'll use this file variable f, which points to our file object, to manipulate and get the data from the file example.txt. Once we have declared this object to be able to look at this example.txt file, we're then able to use built-in methods in the file object to get information and manipulate the file. So for instance, here in this line of code, we are seeing if the file exists. So this is a method to check the existence of example.txt, and we're checking to see if the length of the file is greater than 1000. If this is the case, we are going to delete the file. And here is a list of common file methods. Can read returns whether the file is able to be read. Delete removes the file from the disk just as you would expect it would. Exists checks whether or not the file exists and returns a Boolean value of true or false. GetName returns the name of the file. Length returns the number of characters in the file. And rename renames the file. But to be able to read the data of the file in as input to the program, just declaring a file object is not enough. We need to go one step further. So we also need to declare a scanner object that will look at that file object and use it as a source of input. So just as we use the scanner to look at the system.in, the input stream, we will use a scanner object to point to the file object that we have created. So for the console, we would do new scanner, and then we would give as parameter system.in, which is the input stream, which is where you type into the console. So this would declare a scanner object that looks at the input stream. Very similarly, we can declare a scanner object that looks at a file object. So in this one line of code, notice what we're doing. We are creating a new file object which is going to allow us to look at the file located at file name, and this new file object is being passed as the parameter to this scanner constructor, which will then give us a new scanner object to be able to use to read the input in this file. So here's an example. First of all, we have some file called mydata.txt. We first need a file object. So we're going to declare a variable called myFile of type file. and we're going to assign it a new object, and this object is going to look at mydata.txt. So this is the constructor for the file type, and this builds a file object and gives it to my file. So this file object we can use to invoke the methods that we saw on the previous slide. Now we also need a scanner to be able to read the contents of this file as input. So we declare a scanner variable, we'll call it input, and we are going to construct a new scanner object, and the parameter to the constructor called scanner, the constructor for an object is usually called the same as the name of the class, so the parameter to this constructor is the myFile object. Now this scanner is looking at the object that has access to mydata.txt. And again, we could do this in a single line if we wanted to collapse it and make it a little more compact. Just scanner input, new scanner, and as parameter, new file, with the parameter to the file object constructor being the name of the file that you wish to read. So notice, when we declared a file object and we created a file object, we had an option to check to see if the file which we passed as the parameter actually exists. So understand what's happening here. When we create the file object, we give it an address to a file. So we're saying there's some file at this location in the file system, and we want this object to have access to it. But there's a possibility that the string that we gave for where to go to look at that file is not correct, and it might be that the location in the file system doesn't have a file of that name in that location. So in this case, exists would return false. The method .exists would return false. If you declare a scanner and give a file object that has a non-existent file, it will throw an error. So be careful that you declare the location of your files correctly. There's two ways to tell the file object where to go to look for this file that you want to be able to manipulate. One is an absolute path. This specifies the complete path to a file starting from the top level folder. So in Windows, that might look like C:\document Smith programming assignment 6 input data.csv. It would look very similar in Mac as well, but notice there is a little difference here. Windows can use either backslashes or forward slashes, whereas Mac only uses forward slashes. So for more compatibility, it'd be better to use forward slashes in your programs when you are telling it where to go to look for a file. Another way to give a file's location in the file path is to give a relative path. A relative path is exactly what it sounds like. It is the path relative to some known location. And in IntelliJ, this relative path is going to always be relative to the topmost directory in your IntelliJ project. So when we set up the IntelliJ project, we said the topmost directory would be called CS1101, and then we would just make modules inside of CS1101. So if we were to give a relative path that was just names.dat in Java in the IntelliJ IDE, then names.dat would have to exist in the folder CS1101. If we were to give the relative path input kinglear.txt, what we are telling Java is that inside of the folder CS1101 there is a folder called input, and in that folder there is a file called kinglear.txt. If we were to give this line of code to Java in IntelliJ, then we would be saying that inside the folder CS1101 there's a folder called data, and inside that folder called data there's a file called readme.txt, and I want a file object that looks at readme.txt. And then obviously I want a scanner object that looks at the file object. So the overall process to be able to read the contents of a file goes something like this. First, obviously we need to create a file object. Once the file object is created, we need to create a scanner object which has as parameter the file object. The scanner object will throw an exception if the file doesn't exist. So remember that. If for some reason you type in the location of the file incorrectly, your scanner object is going to throw an exception. That's important. Once the scanner object is created, we're able to read data from the file using the nextInt, nextDouble, next, and nextLine methods, just as we did when they were looking at the console input. We haven't talked about this much, but do remember there are the hasNext, hasNextInt, and hasNextDouble, as well as hasNextLine methods, which allow us to peek at the data without actually consuming it. So we can check to see if there is another token or another line available for consumption without actually using that next token or next line. So just like we can do this on the input stream from the console, we can do this on the input stream that comes from a file. So now to keep things consistent, let's create an I/O folder in IntelliJ to hold all the input and output files for this course. Make sure that you create the file at the project root level, and we'll use a relative path in the programs to be able to access our files so that you don't have to type in the full absolute path. And in this case, a relative path to a file called numbers.txt would just look like iofiles/numbers.txt. Now in the next slide, I'll actually show a video of creating this location and accessing numbers.txt in a program. So here is the IntelliJ IDE, and we have not yet created the folder to house our files. So let's create the folder to house the files. Notice I've selected the topmost folder, and I selected to add new directory and call it IO files. So now we have a folder, and I'm going to add a file to it called numbers.txt. I'll just put some numbers in here to be able to show how we would access those. Now I've made a class file to show how to access these files stored in IO files. So let's write the program real quick. First of all, we need to import java.io.file to be able to get access to the file library. Then we also need to import java.util.star, specifically to get to the scanner. So now let's create our main, public static void, the usual recipe, main, string space args, open close bracket. Now, nope, I'm not going to type that yet. Alright, now let's create our file object. We'll call it inFile. So new, and then the parameter to the constructor is a string which shows the location of the file. So iofiles/numbers.txt. So here's where we have told Java where to go look for this file that we want to read the contents of. We said it's in IO files. So Java understands, okay, we're dealing with a relative path here, and it looks inside the topmost directory, and it says, oh yeah, okay, I see a file called IO files, and then we've said it's called numbers.txt. So it says, okay, yeah, and I see in IO files there's a file called numbers.txt. So we have declared the relative path to numbers.txt. So let's continue at this point by declaring our scanner object. We'll call it file scan. So we have to use the scanner constructor and give as a parameter the file object. Now notice here that when we passed the file object to the scanner constructor, the scanner constructor has a red squiggly line underneath it. That means that there's an error. We can also tell over here because there's a red line showing up on the scroll bar, and there's a red exclamation mark at the top of the scroll bar. Those are all things saying, hey, there's an error in this file. Not to mention the fact that the file name is underlined in red. So you can hover over what is underlined in red to see what the error is. And in this particular case, it says the error is we have an unhandled exception, which means that this scanner object constructor is possibly going to throw an error or throw an exception. And nothing in the code that we've written so far deals with that exception. We're going to talk about exceptions here in a moment, but we've talked about previously in just the last couple of slides how if the file io_files/numbers.txt doesn't exist, then when we declare a scanner object to look at this file object in file, it will throw an error. And the way that it throws that error is by throwing an exception. So Java is saying, hey, this constructor might throw an exception and you're not doing anything about it. And that's going to make it to where we can't compile. So now let's add the code necessary to deal with that problem. So we need to add throws exception to our main. So what that says is we're aware that there's an exception thrown somewhere in this code and we're passing it up to the next layer. So what this says to Java is this main function in this class file IO throws an exception. And by telling Java this, we're passing the buck. This method throws an exception, and rather than dealing with it at this level in the code, we're just passing it up to the next level, and we're not going to do anything about it. And this is how, in this class, we're going to deal with exceptions, just passing the buck up to the main and allowing the main to also throw exception. So now let's print out the first line in our file to show that we're actually accessing it correctly. So system.out.println, we'll use the next line method built into the scanner object. So filescan.nextLine, and we run the code. Oh, yep, 34567. That was the first line of our file, 34567. Good. But now let's print the next three lines as well. So I'll just copy and paste this first line. And immediately as soon as I say I'm going to copy and paste this line, you should be thinking, uh-oh, you're doing something redundant. So it worked though, 34567, empty line, and 34534. But there's a better way that we're going to talk about in the coming slides that I'll quickly show here to be able to print out all the lines in a file. And that is by using the hasNextLine method built into the scanner object. So let's look at how to do that. We'll use a while loop, and we're going to access the filescan.hasNextLine method. So there's many different hasNext. We can check for hasNext integer, byte, but we're looking for line. All right. And then we need our curly braces. We use curly braces even if there's only one line. Oh, and it worked. We printed out all the lines in the file. So understand why this works. We're declaring a while loop and saying we're going to execute this while loop as long as our file scan object has next line. So we're asking this object, do you have another line that I could get access to? And it returns a Boolean. True means yes, there's another line. False means no, there's not another line. So as long as there's another line, we're going to get the line and print it. And we do that until this method says, nope, there's no more lines, at which case we're going to exit the loop and that will end the program. And that works. On the first time through, we say, does the file scan object have another line? Yes. So print that line, 34567. Okay, go back and test again. Does the file scan object now have another line? Yes, it does. Print that line. It was just a new line. So it was just a carriage return. Go back again. Is there another line? Yes. Print that line, 3-4. Test again. Is there another line? No, there is not. So at this point, the program pointer will jump to the statements immediately following the while loop. There are none, so therefore the program completes and terminates. So if you were to attempt to enter the following Java program, you're going to run into the same error I did, which is it's going to say, hey, in line 6, so line 6 is the scanner object creation. In line 6, there's an unreported exception. So, must be caught or declared to be thrown. This is exactly what occurred when, in the video, I tried to create a scanner object, and it underlined the scanner in red, saying, hey, there's a problem here. And we had to add throws exception. So what's happening is when this scanner constructor detects that this file doesn't exist, that generates a runtime error. But rather than just crashing the program, this scanner object constructor method will catch the runtime error and then throw it up to the function that called the method, which happens to be our main. So what's happening here is the scanner constructor method is preventing the runtime error from crashing the program, and instead is handing it up to the next level in case we wanted to implement something to prevent the program from crashing and potentially, display a message and say, file not found, enter the correct file name, or something of that nature. So a more graceful and elegant way of dealing with this error rather than just crashing the program. However, in this class, we're not going to handle errors that fully. So rather than implement the error handling around this function, or around this method call, what we're going to do instead is we're going to, again, just like scanner, the scanner constructor passed the exception up to our level. That's what it's called when we say, that's what's happening when we throw the exception. We're throwing it up to the method above the scanner. So instead of handling that exception, we are also going to throw the exception up to the entity above our main. So this would be the JVM. So instead of handling the exception, we are going to add the keyword throws and exception to tell Java that we are going to hand this exception up to the Java virtual machine rather than handling it ourselves. So what is an exception? An exception is an entity in Java that represents a runtime error. So for instance, if we divided by 0, that could generate an exception. Calling a char on a string, calling char at on a string with an invalid index. So like if the string was only had a length of 5, but we said char at 6, then that would generate an exception. Trying to read the wrong type of value from the scanner. So if the next token were a word such as this, and we attempted to do a next int, then that would throw an exception. Any of these runtime errors that we're discussing here would be exceptions. We say that a program with an error like these throws an exception. And what that means is when we say it throws an exception, that means it hands an exception up to the entity above it. So it's also possible to catch an exception. So some method may throw an exception to the method above it, and that method may catch it. And this would be a way to handle the exception in the program, like we said, in a more graceful way. And that's something that you're going to look at and learn about more fully in 2201. We're not going to deal with that in 1101. So when we open a file using the scanner object, So we give a file object to the scanner. Java is automatically going to check to make sure the file exists, and if it doesn't exist, then the scanner object throws an exception. So we have to choose how we're going to deal with that. And we've talked about two paths, right? We've said we can either catch that exception that is thrown and deal with it in our program in an elegant, graceful way, or we can add keywords to our method to tell Java we want to hand this exception up to the next level, even if that next level happens to be the Java virtual machine, which means that ultimately our program is going to crash. And we said that in this class we're not going to deal with elegant, graceful error handling. Instead, we're going to allow this to be handed up to the JVM, and if this error occurs, if we were to point a scanner object at a file that doesn't exist, our program will crash. And we're okay with that. So we have two options: catch it, or explicitly state that we are going to hand it up and not handle it, in which case the program may crash. So now let's talk about how to tell Java I want to hand the error up to the next entity. So the way that we tell Java that we want the JVM to handle the errors and that we don't intend to is by adding a throws clause, which is a keyword, on the method's header. So for instance, we have a method, so public static, and then whatever type it returns, maybe void, maybe not. Doesn't really matter in this case. The name of the method, any parameters, and then throws, and then whatever it is going to throw. Usually this will be throws exception, with the E in exception being capitalized. So here's an example. And notice that the throws exception goes before the curly brace. So we have our class, then we have public static void, the name of the method, in this case main, just like in our example video, then the arguments to the main function, or the main method, and then after the arguments, or the parameters, but before the curly brace, we have throws file not found exception. So this is a way of telling Java, I know that the main method, or one of the methods that the main method calls, may throw an exception, but I don't want to do anything about it. I want to let the JVM handle it, which means that the program may crash if an exception is thrown. Also notice here, in this version we said throws file not found exception. In the video I used throws exception. Both will work. The file not found exception is a more explicit version of an exception. So an exception is more general. File not found exception is a specific type of exception. So even though we've told Java that we are okay with our file crashing, our program crashing, if an exception occurs, we still don't want it to crash. But we're not going to handle this by using any sort of exception catching. Rather, what we're going to do is, before we actually create our scanner object, we're going to make sure that the file exists. And we're going to use the same approach that we used for input validation from the user. So in this code, we're printing out enter a path for the file, and then the name of the file. And we get the file path from the console, and then we declare a file object which looks at the file path and looks for the file name at that location. Then, inside of a while loop, we're saying if the file doesn't exist, we're using the object file, and the method exists, which is a part of the file class, to see if the file exists at whatever path the user typed in and file name. So if this file exists at that location, this will return true. If this method returns true, then our not will make that false, which means we do not execute this while loop. However, if file.exists returns false, this not will make that true, which means we will execute this while loop. So it's easier to read this maybe than it is to think about the Boolean expression. So when I read this, it should read while not file exists. And then if the file doesn't exist, we are going to say, hey, the file doesn't exist, please try again, and then prompt the user for the file path, get that file path, and then create a new file object with this new file path. Then we will check to see if it exists again. Once this method returns true, which means the Boolean expression would be false, we will immediately exit the while loop and move to the next statement. At that point, we would create the scanner object. So this is a way to make sure that the file exists in the location defined by the file path. So if an input file contained the following information, 23 tab, new line, tab, John Smith, the scanner is going to be able to interpret these tokens in a number of ways. Now, first of all, 23 is an integer, but 23 could also be interpreted as a string. Also, we could promote 23 to be a double. So if we were to use the hasNext int, hasNext double, or hasNext method, all would return true. Also, hasNext line would return true. 3.14 can be interpreted as a double or a string. However, it can't be interpreted as an integer. And then double quote John can be interpreted only as a string, as well as Smith, double quote, can only be interpreted as a string. So this is the possible interpretations of the tokens in this file. So if our numbers.txt file contained 308.4, new line, tab, 14.8, 7.3, 2.9, so forth, what the scanner actually is seeing is a single stream of characters like this. 308.4, new line, and either 3 spaces or a tab, can't tell, but it's obviously 3 spaces, otherwise this would be a /t. So 3 spaces, 14.8 space, 7.3 space, 2.9, new line, 3.1. So this single stream of characters is what actually exists from the scanner's point of view. So then when we begin to read from this stream, this input stream, we'll talk about the input pointer. And that's referring to the current position of the scanner in the input file. So when we first open the file with the scanner object, the input pointer is going to be pointing at the very first thing in the file. When we call methods like next double on the scanner object, we are consuming some of the input stream and advancing the cursor. So when we call next double and it returns 308.4, that returning 308.4 and advancing the cursor is referred to as consuming input, because you have moved the input pointer, so 308.4 no longer is available for consumption. It is already being consumed from the input stream. So initially, when we called, or when we constructed our scanner object, the input pointer was pointing at 308.4. But then in our program, we called input.nextDouble. And this is going to return the next token interpreted as a double up till the next white space. White space would be a new line, a tab, or space. So it got the token, which started from the current input pointer location until the next white space, and interpreted that as a double, which would be 308.4, and returned that and assigned it to the variable myDouble. Okay, now the input pointer is pointing at this new line. In the next line of the program, we're going to use the next method, which is part of the scanner object, to get the next token interpreted as a string. So we start from the current input pointer, and we are going to consume everything until we find a token, and we are going to know that we have found the end of the token when we see white space. So when this method is called, it will ignore the new line, ignore all the white space, return the token, and stop at the next white space. So it returns the string 14.8. And the new input pointer location is the space following 14.8. So to test our understanding, let's write a program called echo.java that reads the first 5 doubles from the file and prints them along with their sum. So the output should look something like this: 308.4, 14.8, 7.3, 29, 31, and then 336.5. So here's a program that we think will be able to read these 5 numbers in from the file and display their sum at the end. So let's talk through it. So first of all, notice the documentation. It tells what it's supposed to do. Good. We're importing java.io to be able to make use of the file library. We're importing java.util to make use of the scanner library. And we're not just importing java.io.file, but we're importing java.io.star, which means we're getting every class from the java.io library. The same thing is true for our import of java.util. We're using the .star to get all the classes which are a part of the java.util library. Then we are declaring our class, which we're calling echo. Then we declare the main method in the echo class, public static void main, and then our usual string args. Now notice we follow the parameters by throws file not found exception. So we're telling Java we're going to allow the main method to pass any exception that occurs in the main method up to the next entity. We don't want to deal with it. We'll let whatever is above the main deal with it. In this case, the only thing above the main is going to be the Java virtual machine. So we've dealt with our little exception problem that we've encountered. Now let's declare our file and scanner objects. So we create a new file object which points at our numbers.txt file, and a new scanner object that looks at our new file object. We call this scanner input. Now let's declare a variable called sum of type double and initialize it with the value 0.0. Now we're going to use a for loop to read 5 doubles from the file. So we're going from 1 to 5 inclusively. So we're going to do this 5 times since we're incrementing by 1 in our update. And we're going to read the next double into next num, and we're going to print that number and then increment sum by that number. We'll do this 5 times and then print the sum. Now let's modify this file to read the first 5 tokens rather than expecting them to be doubles. So here we've made the modifications. So we are going to keep most of it the same. We're going to change the class name to echo2, and we are going to use a for loop to read the first 5 tokens, And we're going to use, rather than next double, we're going to use input.next, which is going to read the next token from the input object stream. And we're going to store it in the variable called next, which is of type string, and then we will print it out to the console. But what if we wanted to modify our program so that instead of saying we want to read the first 5 values or the first n values, we say we want to read all of the values that are in the file? We discussed this briefly in the video where we used a while loop to be able to read each line of the file. Here we don't want to read lines of the file necessarily, we want to read each token until we have read the entire file. So this seems like an event-controlled loop situation, read until some event occurs, but what event do we need to look for? What method do we need to use to look for the end of the file and know to stop reading in so that we don't cause a runtime error? So recall the helpful methods that we use for reading data. hasNext, hasNextInt, hasNextDouble, and hasNextLine. These methods can be used to tell if the next token exists, or if there is a next token, if the next token is an integer, if there is a next token that is a double, or if there is another line. So these methods don't consume input, so they don't move the input stream pointer, but they do peek to tell us what is in the input stream. So we can use these to avoid reading the wrong kind of data at the wrong time. So if we were to attempt to read the next int, but the next token were a word, that would cause a runtime error. Using hasNextInt will return true or false, but won't cause a runtime error if there is not an integer on the input stream in the next token's location. It also won't move the input stream pointer, so that after checking to see if the int exists, we can choose whether or not to consume it. So if we want to detect the end of a file, we can use the input.hasNext method to see if there is another token. As long as there is another token, we will read the next token, store it in the variable token, and print it to the output stream. And we will continue until hasNext returns false, which means there are no more tokens, and we will exit this loop. This is a better way to read the entire file because now we won't crash, because when the end of the file occurs, we will not attempt to read a token that exists after the end of the file. Obviously that can't happen, right? We can't read things that don't exist, so that would cause a runtime error. This prevents us from encountering that runtime error. So now let's use these helpful methods to modify our echo program to process the entire input file, reading in all of the tokens as doubles, and then printing the sum. So let's look through this code to see if it will do exactly what we described. We're importing the java.io to get use of the file class and java.util to make use of the scanner class. We're calling this class echo3. We have our public static void main method, which throws file not found exception. Then we're declaring a scanner object that's going to look at the file numbers.txt. We're declaring our sum variable of type double and initializing it to 0. And then, rather than using a for loop for a given number of reads, we are going to say, as long as there exists another token that can be interpreted as a double, continue to do this. So while input.hasNextDouble, read the next double from the input object, store it in next, print it, and increment the sum by the value stored in next. And we will do this until input.hasNextDouble returns false. That would mean that the next token in the input stream is not something that can be interpreted as a double, or we've reached the end of the file. Either way, this will return false, which means we will exit the loop and jump to the statement immediately following the loop and print the sum. So just because this returns false does not mean we found the end of the file. What it means is that the next token on the input stream is not something that can be interpreted as a double. So either way, if we were to attempt to read something that was not interpretable as a double, or if we attempted to read something after the end of the file, we would encounter an exception. So this code allows us to read all of the doubles that occur in this file until we find a token that cannot be interpreted as a double, or we encounter the end of the file. But notice that's still not necessarily exactly what we want, because maybe there's words mixed in. So 308.4, hello, 14.9, 7.3, bad stuff, 2.9. In this case, as soon as the input pointer looks at the token hello, it will return false when we call the method hasNextDouble. But we've not found the end of the file. We just have found a token that can't be read as a double. So we want to modify our program so that rather than stopping and saying we can't read anymore, we ignore these tokens that can't be read as doubles. To get this functionality, we don't have to change much, but we do have to make an important change. First of all, rather than using input.hasNextDouble as our while loop test, we will use input.hasNext. So we're going to keep processing the file as long as there is anything left to process. So as long as there are more tokens in the file, we're going to continue to process it. Then inside this while loop, instead of directly processing the input as a double, we have to check, are we dealing with a double? So if the next token is a double, so if input.hasNextDouble is true, we will get the next double, store it in next, and then print it and increment sum by the value in next. However, if the next token is not a double, we will instead execute the statements in the else statement, in which case we are going to get the next token by calling the input.next. But notice we're not going to store this value in a variable. So all this does is consume the next token. It just gets it out of our way. And it moves the input pointer in the input stream to the next token. And so we hit the end of the loop, jump back to the test, and check again. Are there more tokens left in the file? If yes, we check to see if that token is a double. If it is, we're going to add it to the sum. If it's not a double, we are going to consume it and move the input pointer to the next token. Then return again to check to see if that token is a double. We are going to do this until the while loop test says there are no more tokens in the file. So when input.hasNext returns false, that means there are no more tokens in the file, and our program pointer will jump to the statement following the while loop, and we'll print out the sum. So let's look at one more example program. Consider the task of reading in the file hours.txt and summing up all the hours worked by an individual person and finding out how many hours they worked per day. we have the employee ID followed by the employee's name, and then Vicky worked 12.5 hours followed by 8.1, then 7.6, and 3.2. So there are 4 entries for the number of hours worked. However, Brad has 1, 2, 3, 4, 5 entries for the number of hours worked. So the number of hours entries for each person may vary. So we wouldn't be able to say read the first int, then read the next token, then read 4 doubles. We can't define that sort of an algorithm to read in this hours.txt file because the number of hours entries is going to vary for each person. So maybe instead of attempting to read it in this way, maybe we should attempt it token by token. Here's some code that looks like it should work, but it doesn't. Can you see why? We're importing the file class and the scanner class. All our syntax is good. We have our main method. It throws file not found exception. Doing good. We have the scanner object called input we have created. And then we say, while we are not at the end of the file yet, so while there are more tokens to process, let's process. And for each person, we read in their ID, their name. We said we couldn't do it formulaic like this, but let's see if it works. Then we read in, or we create the variable total hours and days, and we have a nested while loop, and we're going to, that's what we're going to do. We're going to read in all the doubles. So while there's another double to read, we're going to keep reading doubles. So in the example from the previous slide, we saw they had an employee ID, their name, and then a sequence of doubles that were the number of hours worked. So, okay, we're going to try to read in all the doubles until we see no more doubles to read, and then we will print out their information and start on the next person. That's a good idea. However, this code doesn't work. The reason it doesn't work is because the hasNext double method will return true on the next person's employee ID. So it will read all of the hours worked, and it will get to the new line, and then it will move the input pointer to the next token, which will be the employee ID for the next person. And we said that hasNext double will return true for integers as well, because an integer can be promoted to a double. So this will wind up reading in the next person's employee ID as part of the hours worked. So this method does not work out for us. So ultimately what's going to happen is we're going to attempt to read in an integer where we should be reading in a token, because we're going to read in their employee ID as a double, and then the next item in the file is going to be not a double, it's going to be a string, and so our interior while loop is going to exit, and we're going to check to see if there are more tokens. It's going to say yes, and the first line in our while loop reads in the employee ID as a token, or as an integer token. Well, the problem is our input pointer is going to be pointing at the person's name, and we're going to attempt to read it into an integer. This is going to cause a runtime error, so it's going to throw an exception, and the program will crash. So we want to process one person at a time, and we know that one person takes up one line and is separated from the next person by a new line character. So how could we use this structure where each person occupies one line and they're separated from the next person by a new line character to better read in this file and calculate the number of hours worked for each person? So maybe we could break the overall input file into lines and then break each line into tokens and process each of those tokens. We will pick up with this in our next lecture.